Hello everyone, hope you're doing great. Welcome to my channel, The Consistent Coder. So today the problem we are going to discuss is the climbing stairs. You are climbing a staircase, it takes n steps to reach the top. Each time you either climb one step or two steps, in how many distinct ways can you climb to the top? So we were given a number n equal to 2 here in the example 1, and we have to tell how many different ways can we reach to the top. So I'm starting at the bottom, let's say that is n equal to 0, and from n equal to 0 I'll take one step in order to reach the step number 1, and then I'll take one more step to reach the top. So that is one way. Or I can take two steps directly from n equal to 0 in order to reach the top n equal to 2, hence that is second way. So here we have two different ways, right? So hence we'll return 2, which is the output. Let's see the example where n equal to 3. So we'll take one step and one step. This is one way to do it. Or we can take one step and then two steps. Yes, this way also we'll reach the top. Or we can take two steps from n equal to 0 in order to reach the step n equal to 2. And then I'll take one more step in order to reach the n equal to 3, the top. So here we have three different ways, right? Hence we'll return 3. Let's see how we can solve this problem. Let's say n equal to 5, and I have to calculate how many different ways I have to reach the top n equal to 5. Okay, so I'm trying to first come up with a solution that is recursive, and then we'll talk about the iterative solution. Okay, in the recursive solution, we always start from the top to the bottom. So we'll try to start from the back. Let's say I assume that I have already reached the top. Okay, and now I'll see if I had reached the top, what are the different ways I could have reached there? If suppose I am tracking the previous step where I have come from. So I could have come from n equal to 4 to n equal to 5. Why? Because from 4 I will take one step and then I'll reach 5. Or I could have come from 3 where I have taken two steps, correct, in order to reach the step number 5. Okay, can I come from step 2 to step 5 directly in one step? No, because in order to come from step 2 to step 5, I would have needed to take 3 steps, but it is mentioned in the question that I'm allowed to take only one step or two steps. So if I had reached 5, I could have either come from 4 or I could have come from 3, right? So let's represent it this way. So if I had to talk about the number of ways I had reached the step number 5, it will be basically the number of ways I could have reached the step number 3 plus the number of ways I could have reached step number 4. Because there is no other possibility that I could have reached, step number 5. I could not have reached step number 5 from step number 2 or any other step except for 3 and 4, because that is where there is a possibility where I could have taken one step or two steps, right? So number of ways I could have reached 5 is number of ways I could have reached the step number 4 plus number of ways I could have reached the step number 3. Again, if suppose I'm talking about the number of ways I could have reached the step number 4, so how could I reach step number 4? I could have either come from step number 3 or I could have come from step number 2, right? Because I could not come from step number 1 in one step, right? What I mean by step is that by taking either one step or two steps, I could not reach step number 4 from step number 1. I could have only come to step number 4 from either step 3 or from step 2, because that is the only possibility. So number of ways I could have reached step number 4 is number of ways I could have reached the step number 3 plus number of ways I could have reached the step number 2. Same goes for step number n of 3 as well. So if I had reached the step number 3, that means I could have come from step number 2 or I could have come from step number 1, correct? So because there is no other way, I could not come from step number 0 to 3 directly, because 3 steps is not allowed, right? So this will be number of ways I have reached, to step number 2 plus the number of ways I've reached step number 1. If I sum it up, I'll get the number of ways I could have reached step number 3. So same again we have this calculation. So here if you observe that in order to in the previous step itself we have already calculated number of ways I could have reached step number 3, but again we are calculating it again. So this is the problem with recursion. So we are actually basically doing the calculations that we have previously done before. So in order to avoid this, we can use a memoized hash map something, so that what we do is whenever we calculate a result, we store it in our hash map. So if we have to need to access those values again, we don't need to recalculate them, we just access our hash map and then we'll return those values. So this will be again number of 1 n of 1 plus n of 2, right? So plus Here I'll have n of 2 the same again. So this particular thing came from this n of 3, and then I'm writing the n of 2, and then n of 2 we already know that is 2, right? Because we have seen the base case. Let's assume that's the base case. Base cases are basically n equal to 1 and n equal to 2. We already know what is the answer for that. So for this also it's 1, for this it's 2, and then for this it's 2, and then for this it's 2, and then for this it's 1. So basically 1 plus 2, 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 1 is 8. So basically there are 8 different ways I could have reached the step number 5. Correct. But since I don't want to do it the recursive way, how do I actually solve it with the iterative way? Say for example, I have the array, right? So this is the array. This is the step number 1. Let's say step number 1, step number 2, step number 3, 4, 5, and then 6. Let's say, okay. Let's say in this particular array, I'm only storing the values that are, the distinct number of ways I could reach this particular step. So if that is the case, how many different ways I could actually reach to the first step? There is only one way, correct? Because from 0 to 1, there is only one step. There is only one way I could have reached step number 2, step number 1, correct? If I had to reach the step number 2, how many different ways are there? There are 2 ways, because we know from 0 I could have gone to 1, and then from 1 to 2, that is one way, or I could have directly gone from 0 to 2. That is another way. So there are 2 ways. Now from this logic that we have just talked about, the number of ways I could have reached the step number 5 is either I could have come from step number 4, where I'll take 1 step to reach the step number 5, or I could have come from step number 3, where I've taken 2 steps. So with that logic, if I have to reach the step number 3, so what do I need to do? I just need to know how many different ways I could have reached the previous step, plus how many different ways I could have reached from the previous of that previous step. Why? Because from this step number 1, I could take 2 steps and then reach number 3. And similarly, from step number 2, I could simply take 1 step and then reach step number 3. So basically, if I just add it up, n of 3, number of ways I can reach step number 3 is basically n of 1 plus n of 2, right? Because the distinct ways I could reach the step number 2 plus step number 1 are the total possibilities I could reach step number 3. There is no other possibility, correct? So this will basically be what? 1 plus 2, which is 3. Okay. Now what about 4? So what about step number 4? The step number 4, I could have reached it by either coming from step number 3 or from step number 2. There is no other possibility way, right? So basically the number of ways I could reach step number 3 is 3, and the number of ways I could reach step number 2 is 2 ways. So that is 5, correct? And then if I had to talk about the number of ways I have reached step number 5 is basically the number of ways I could have reached step number 4 plus number of ways I could have reached step number 3, which is 3 plus 5, which is 8. If you see, this is what we have got in the recursive solution as well, right? Right. So the number of ways I could have reached step number 5 is basically 8. And same goes for, however long the steps we need, we'll, simply calculate it accordingly. So for 6, again, it will be 8 plus 5, which is 13, and then 13 plus 8, and so on. We'll do the calculations as needed based on the value that we need to reach the top. Okay, let's code it up. So let's maintain an array. Let us call this a DP. Now what I'm trying to do is I'm trying to have an array that has a length of only n. Why? Because I don't need to have more number of steps in my array than what is needed, right? So I'll simply maintain a length that is equal to n. Okay, and we know that we are assuming, if we look at it, we are assuming that this is the first step, right? But this is actually 0th index, right? If we are talking about indices, this will be 0, 1, 2, 3, and then 4, and then 5. But this is actually step number 1. So what will be DP at 0? This is basically step number 1. There is only one way that I could have reached there. And then if I'm talking about DP at 1, that is step number 2. The number of ways I can reach step number 2 is 2 ways. And then for the rest of them, I can simply write for I equal to 2, I less than n, I plus plus. If I have talked about the number of ways I could have reached the step number I is basically the number of ways I have reached the previous step plus the number of ways I could reach the previous of this previous step, which is dp at I minus 2, right? So that's it. And now what we need to do is we simply need to return the final step, right, will simply return the number of ways I can actually return, I can actually reach to the top, which is n-1. Why n-1? Because we're talking about the indices, right? If we have talked about this, the number of ways I could reach the step number 6, that means I need to return dp at 5. Why? Because dp at 5 represents the step number. So because we are dealing with indices, we have to do -1. So let's see if this is working. Yeah, as you can see, this is working fine. And then I'll submit. Yeah, as you can see, it is running fairly faster as well. So yeah, that's how you can do it. There is one more way you can do it. You can actually do it with recursion as well. But when you're doing with recursion, make sure you memorize it. So for example, as we have seen here, to calculate the number of ways, to reach 5, we are calculating n of 4 plus n of 3. Again, we are calculating n of 3. In order to calculate the number of ways I have to reach this step number 4. So make sure to memorize those results and then move forward. Yeah, other than that, that's it. That's it for the video, guys. If you have liked the video, please do give a like, and please do consider subscribing if you like my content and wanted to receive weekly content as well. Yeah, thank you. Bye.